we have an example before us here, and that example says a string of mass per unit length 2.0 times 10 raised to the power minus 2 kilogram per meter is under a tension of 20 Newton. What is the speed of the wave formed when the string is set to vibration? Okay, so the solution would be the following. And of course, the first things that you do when you have a physics problem is to write out your parameters. It goes a way to help. It goes a very, very long way to help to write down your parameters. When you have your parameters, it would help you to decide what formulas exactly it is that you want to use per time. Okay, so here we have mass per unit length, which is m equals 2.0 times 10 to the minus 2 kilogram per meter, and then it is under a tension of 20 Newton. That is tension T is equal to 20 Newton. What is the speed? And we are asked for the speed. Good. So clearly you have these three parameters, which is one of the last things that we just did. So therefore V is equal to the square root of tension over mass. Okay, tension over mass. So what does that tell us? That tells us that the velocity we are looking for is equal to the square root of 20 over 2.0 times 10 to the minus 2. And if you do that calculation, you will have that V is equal to 31.622 meters per second. That's simple, quite simple. 31.622 meters per second. It's just as simple as that. Okay, so here's another question. A note of frequency 300 Hz is produced when the length of a wire is 80 centimeter and tension is 40 Newton. What is the frequency if the length of the wire is halved and the tension is doubled? Wow. So as usual, let's write out our parameters. Okay, so here we have frequency is 300 Hz. 300 Hz. It's 300 Hz, right? So frequency is 300 Hz. I want to call that frequency 1, 300 Hz. And I want to call it length 1. Length 1 is 80 centimeter. And that of course should be 0.8 meters. That is dividing by 100 because you want to move it from centimeter to meter, which is the standard unit. And tension T is equal to 40 Newton, and I want to call that T1. And then we are also said, what is the frequency? So there's also another frequency they are asking, F2. What is the frequency if the length of the wire, so we have another length, L2, is halved? That is 0.8 divided by 2, which should be 0.4. The length is halved to 0.4, and the tension is doubled. Wow. So T2 will be 2 times 40, which is 80 Newton. Okay, now notice that in the whole of this question, there is no mention of mass. That is because from the question, it is inferred from the question that the mass is constant, because we're saying a note of frequency is produced when the length of a wire. Okay, so we see a wire, and then what is the frequency if the length of the wire, that is the same wire, so the mass of the wire, the thickness of the wire has not changed, so thickness is constant, quite constant. Now if you have a situation like that where one of the three properties or the three features of a string is missing, okay, you can always ignore that if it is not part of the question. Just like this, it is not the mass, the thickness is not part of this question. It wasn't given as a parameter, and it wasn't also required that we find it, so we're just going to treat it that it's a constant. Okay, so by the time we are writing the equation that we're going to use, we will simply avoid that. So you remember that generally the equation that we have says that f is directly proportional to 1 over L, then the square root of T over M. Now we do not have an M. Okay, so what we're going to use is that f is directly proportional to 1 over L, then the square root of T. That's it. That's what we're going to use. Now, why do we have two different sets? If you look carefully, you will realize that one set is complete, right? This set is complete. We have F1, L1, and T1. So what exactly are they meaning? The point is, this is still the proportionality constant. So F is going to be equal to K over L, the square root of T. We need to find K. That's why we have all of this. We have the totality of this. We have all of this given because we're supposed to find, we'll have to find the K, and then the K is a constant, is the constant for the wire. So if we find the K, the same K, we are also going to transfer into this other part of the equation, and then we'll make this the subject. So how do we do that? We simply say F1, which is 300, is equal to K over L is 0.8 times the square root of 40. 300 equals K over 0.8 times the square root of 40. Okay, so if we continue with that, I am going to have 300 is equal to 0.8 times no, not that. I am trying to cross multiply. Yeah, I will have times 0.8 is going to be equal to root 40k. Therefore, k will be equal to 300 times 0.8 divided by the square root of 40, divided by the square root of 40. And if you punch that in your calculator, you will have 240 over root 40. The square root of 40 is equal to 6.324. And when you do that division, you have 37.950. So K is equal to 37.950. Okay, 37.950. All right, we'll wipe this one because we are done with it and we need more space to tidy up that other question. We need some more space. Okay, so now we found the value of K. Okay, we found the value of K. So we are going to rewrite the equation for this one and then insert the value of K. So the equation for that will be, remember, do not forget that this is F1, this is L1, and this is also T1. So F2 will be equal to the same K because that's a constant over L2 then times the square root of T2. What is our F2? That's what we're looking for. We don't have that value yet. That's the value we are required to find. So F2 will be equal to, what's the value of K? Our value of K is 37.950 divided by L2. The value of L2 is 0.45, 0.4 meters, then times the square root of our T, which is 80. Our T, which is 80. So quickly dealing with that, we'll have that F2 is equal to 37.950 times, what is the square root of 80? Square root of 80 is 8.944. 8.944 divided by 0.4. So 37.950 times 8.944 is, this will be equal to 339.424 divided by 0.4. 339.424 divided by 0.4, which is going to be equal to 848.56 hertz. So yeah, we have found the frequency if the length of the wire is halved and the tension is doubled. So you see, it's as easy as just remembering, oh, this is actually what I need to impute in this place. This is writing out the parameters. Once you are able to write out, I've come to find out that the reason why some people really fail physics problems is because they fail to write out parameters. Okay, if you write out these parameters, when you look at them, they begin to take a certain shape in your mind to say, okay, when I bring this variable and that variable together, there is actually a formula that contains each of the variables that we're looking for. If you're able to write out your parameters correctly, understand the questions correctly, write out your parameters, everything becomes quite easy.